Solve x plus 4 over x minus 2 is less than or equal to x. So we start by rearranging this into an inequality less than or equal to 0. Combine this into a single rational function by getting a common denominator of x minus 2. And then add these together. So I'm going to get minus x squared. I've got x minus 2x, so plus 2x, so plus 3x in this case. And then plus 4, all over x minus 2. Now to look at this, I'm going to factorize the top because I think it's going to be a little bit easier to have it in factorized form. Normally is. So x squared minus 3x minus 4 first of all, which I can factorize to x minus 4 x plus 1 all over x minus 2. Now I'm going to look at the two different cases. The things, if this fraction is negative, then there are two possibilities. Either minus x minus 4 x plus 1, either that is, first of all, we'll say that that is negative. And if that is negative, and then the denominator, x minus 2, has to be positive. So either this is negative and this is positive, where this can be equal to 0, but this can't. Or the other possibility is when the numerator is positive and the denominator is negative. So let's look at these one at a time. First of all, we'll solve this one. How am I going to solve that quadratic inequality? Well, I'm going to solve that by graphing it. So graphing the quadratic inequality. It's a negative quadratic going through minus 1 and 4. When is that less than 0? It is this bit and this bit. So that is when x is less than negative 1 or x is greater than 4. So we need that to be true. And we need this to be true, that is x is greater than 2. So when are both of these things true? Let's think about what this looks like. This one is saying either x is less than negative 1 or x is greater than 4. And this one is saying x is greater than 2. When are both those things true? It is when x is greater than 4. Okay, well, actually it's greater than or equal to, because these ones should have had the equality on, because my quadratic actually, remember, can be equal to. So these two should be filled in ones, which means it's greater than or equal to 4. So that's one possible solution to this inequality. Now let's look at the other side. The quadratic, we've already drawn the graph. When is this one bigger than 0? That's this bit over here. So it's bigger than 0 between minus 1 and 4, and let's remember the equality signs this time. So if that is true and x is less than 0, sorry, x is less than, not 0, x is less than 2 when I rearrange this one. So again, let's think about it this time. This is saying, the quadratic bit is saying anything between minus 1 and 4, and this one is saying anything less than 2. When are both of these things true? Well, it's this bit here where they're both true. It's between minus 1, including minus 1, and 2. So that is the second part of our solution to this inequality. X is greater than or equal to 4, or when x is greater than or equal to negative 1, but less than 2. Either of those two things are true, then this inequality is true. Let us look at this problem graphically. We're going to draw the graph of x plus 4, x minus 2, and also y equals x. And we are interested when this one is less than y equals x. So that is when the red line is below the blue line. And we can see that this happens in two places. Either to the right of this point here, the red line is below the blue line. So that is when x is greater than or equal to 4. And the other time that it happens is this bit here, between this point and that vertical asymptote. So that's less than or equal to, so greater than or equal to -1, but less than the vertical asymptote, which is at 2. So between -1, including -1, and 2, not including 2. We can see that graphically matches up with what we found analytically by solving the inequality using algebra.